the semester. And it's going to be a really straightforward video. I think you will find it familiar because you learned a little bit of this in middle school. So we're going to talk about the law of the conservation of mass. And the law of the conservation of mass states that matter, which matter has mass, cannot be created nor destroyed. Cannot be created nor destroyed in a chemical reaction. So the conservation of mass says that matter cannot be created nor destroyed in a chemical reaction. And really what that means is that the mass that we start with is going to be equal to the mass that we end with. In other words, the mass of all of the reactants after they react will equal the mass of all the products. So what that means is, here's an example. Let's say we start with 10 grams. Well, if we start with 10 grams of reactants, that will mean that we will end with 10 grams of products. So if we start with 10 grams of reactants, we will end with 10 grams of products. You cannot create nor destroy matter. So if we start with 10 grams, we end with 10 grams. All right, so let's go ahead and take a look at these practice problems. This is going to be super easy. So in this chemical reaction, notice how we start off with this here. These are called reactants, and reactants are what you start with. And these are products. And so the mass of these has to equal the mass of that. So the mass of the reactants will equal the mass of the products. And so if you take a look in this first example here, there's 10 grams of Cl2, which is chlorine gas. So there's 10 grams of this, and there's 5 grams of this. And what happens is these will react with each other. And when they react with each other, it says that 12 grams of aluminum chloride are produced. So 12 grams of aluminum chloride are produced. And the question is, how many grams of this are there? How many grams of F2 are there? Well, again, whatever this is has to equal this. And so if you take a look, I think a lot of you will see the answer is 3. Again, we're starting with a total of, if you take a look, we're starting with a total of 15 grams. And so if we start with 15 grams, we have to end with 15 grams. Well, this here is 12 grams. So what must this be? That must be 3. And so the answer here is 3 grams of fluorine gas. All right, let's do the next one. Okay, the next one says 25 grams of this It reacts with this, and it produces 35 grams of aluminum chloride, and it produces 7 grams of this. And the question is, well, how much of this must there have been? How much of there must there have been? Well, again, this has to equal this. Really easy. Whatever you start with has to equal whatever you end with. So you kind of work backwards here. And so we know that this right here is equal to 42. And so we know that because that's equal to 42, that means we must start with 42 grams. And so if we have 25 grams of chlorine gas, how many grams of the aluminum fluoride are there? And so again, you just do some simple algebra, the 42 minus the 25, and that gives you 17. So that means there's 17 grams of the aluminum fluoride. All right, so let's go ahead and do this next one here. Now this one is a little bit different. You need to make sure you're carefully reading what it's asking. It says if 6 grams of chlorine gas reacts with 8 grams of aluminum fluoride, okay, so we have 6 grams of this and 8 grams of this. The question is, what is the total mass of products? So what is it asking for? It's asking for the total mass of the products. And so these right here are the products. And so it's not asking for the mass of either of those. It's asking for the mass of both of those. It wants to know, what will the total grams be? Well, again, we're starting with 6 grams of chlorine gas and 8 grams of aluminum fluoride. So that means that if we're starting with 6 grams of one and 8 grams of the other, that means we're going to end with a total of 14 grams of products. And this is our answer. So easy peasy. Now let's go ahead and talk about how we need to satisfy the law of the conservation of mass when writing a chemical reaction. And so before we take these notes here, I'm going to show you a chemical reaction. So here's an example of a chemical reaction. And so this is an example of a synthesis. We will talk about how we know it's a synthesis later. We don't need to know that for now. But if you take a look at this particular chemical reaction, there's actually something wrong with it. And what is wrong with it is that we're starting with 8 sulfurs and we're ending with 1 sulfur. So we're starting with 8 sulfurs, we're ending with 1. The other thing too is we're starting with 2 oxygens and we're ending with 3 oxygens. And according to the law of the conservation of mass, you cannot create nor destroy matter. And so it appears as if we're somehow destroying some sulfur, and it appears as if we're somehow creating oxygen, and so that cannot happen. So they can't happen. So what we're going to do is we're going to talk about how we can balance chemical equations so that we can satisfy the law of the conservation of mass. So let's go ahead and talk about how we can balance chemical equations. And so before you even get started with writing a balanced chemical equation, what you need to do is you need to have an equation with all the chemical formulas written correctly. And so to give you an example, sodium chloride is NaCl. That is the formula for sodium chloride. The formula for magnesium chloride is MgCl2. And these are the correct formulas. However, what if you put a 3 right here? Well, that would make this not correct. What if you put a 4 right here? That would make this not correct. And so you need to have correct chemical formulas. Now, what I'll say is if you look at these here, these are already giving you the correct chemical formulas. You don't need to worry about making sure they're correct if it gives it to you like this. All right. Then what you need to do is you need to see what you have by counting all of the atoms present. So you need to count how many atoms there are of each type on either side. And so what I'm going to do is I'm going to go ahead and do this step here. So let's go ahead and we're going to write all of the elements that are present. So we have sulfur and we have oxygen. And so I like to sort of write these colons here so that it kind of helps us separate it. And so what we're going to do is we're going to count how many sulfurs there are on either side and how many oxygens there are. Now, if you take a look, this subscript right there tells us that there's 8 sulfurs. And so on the left side, there's 8. And on the right side, you can see there's nothing there. If there's nothing there, we assume that it is a 1. Okay, let's go ahead and do the oxygen. So we have 2 oxygens here, and we have 3 oxygens here. And that is, we just counted them. Now, obviously, the sulfur and the oxygen are not balanced, and so let's go ahead and talk about the next step. So we just did step 2 there. Now, step 3 is what we want to do is we want to write numbers, which we call coefficients, in front of each box until the total count for each element is the same on both sides of the arrow. Now, to get the total count, what you do is the coefficients multiply the subscripts. And so whatever you put in front of a formula, you have to put a number that multiplies the coefficient, and it multiplies it so that it's equal on both sides. And whatever you put in front of a compound, whatever coefficient you put in front of a compound, it multiplies all of the elements or ions in that compound. So let's go ahead. I'm going to do an example here. So when you're looking at this, what I will say is it doesn't matter if you pick sulfur first or oxygen, right? It doesn't matter. You can pick either one. Except I will say that in most situations you want to save oxygen for last. All right, so in these examples here, actually they all have oxygens. Okay, so in this last one, this doesn't have oxygen here, so it does not matter which one you save for last. But usually you want to save oxygens for last. So just keep that in mind. Most chemical equations work out to save the oxygen for last. So the only thing you can do is you can put large numbers in the front, and whatever number you put there multiplies that element. All right, so again, I'm going to say this again. Whatever number you put there will multiply that element, the number of that element. Now, if I put something here, this is going to multiply the number of sulfurs, but it's also going to multiply the number of oxygens as well. If I put a large number here, it's going to only multiply the sulfur. So, if we take a look here, we have 8 on the left, 1 on the right. What do we need to put here that multiplies this to give us 8? Well, there's 1 sulfur, and we know that 8 times 1 is 8. And so if we put an 8 here, that actually fixes this sulfur. So now the sulfurs are balanced. Now, something we need to keep in mind, and before I move forward, I'm gonna restate this. We put an 8 here so that we can balance the sulfurs, because we know that if we have 8 sulfurs here, we need to somehow have 8 sulfurs over here. All right. Now, this 8 does not only multiply the sulfur. What else does it multiply? It multiplies this oxygen as well. So we no longer have 3 oxygens. We now have 24 oxygens, because 8 times 3 is 24. So when we put this coefficient in the front, it doesn't multiply just the sulfur, it multiplies the oxygen as well. All right, so now what we want to do is we've got this fixed. All right, we're all good. Let's go ahead and move to the next one. Now, we need to fix oxygen. The oxygens are not balanced. And again, the only thing you can do is put large numbers in the front that multiply that to give us the right number. And so what do we need to put here to multiply the 2 oxygens to give us 24? We need to put 12. When we put 12 here, the 12 multiplies the 2, and we no longer have 2, but we have 24. And now that is fixed. And that's it. It's really easy. What I will say is it does take a moment to kind of get used to it, and you'll see that there's like, a certain, amount of practice that you'll need to do to get the hang of it, but it's not too bad. Now, one thing I want to say is, does this 12 multiply this? Does it multiply this sulfur? And the answer is no, it does not. This 8 multiplies this sulfur and the oxygen because those sulfur and oxygen are together. Now, what about here, though? We put nothing here. So what is actually there? Well, there's a 1 here. There's a 1 there. And so if there's nothing there, if we don't need to put anything, that means there's a 1. All right, and you can write the 1 or you can choose not to. Typically, we don't write the 1, but if you want to write it, you totally can. All right. So let's go ahead and move on to the next one. All right, so we have iron, we have oxygen, we have 2 oxygen here, 3 over here, we have 1 iron, 2 irons. And so let's go ahead and fix this. Now, when this particular problem actually is a great example of something that I want to show you. All right, so we're going to go ahead and fix the iron first. What you need to do is you need to put a 2 right here to fix the iron, because when you put a 2 there, it multiplies the iron to where we don't have 1, but we have 2 now. And again, we typically want to save the oxygens for last. But let's go ahead and do the oxygens now. So let's go ahead and do the oxygens. The oxygen, if you take a look, there's 2 on this side and 3 on this side. So how do we make them equal each other? I know there's someone that's going to want to put 1.5 here, but you can't do this. You cannot just put 1.5 there, because what you need to do is you need to put whole numbers there. It can't be a decimal. It has to be a whole number. So the question I'm going to ask you is, how do we put a whole number here to make these equal each other? Well, what you want to do is you want to think, well, what can both of these become? They can both become 6. How do we make this 6? We make this 6 by putting a 3 here. And when we put a 3 here, this is no longer 2, but 6. Okay, so how do we make this 6? By putting a 2 right here. And this no longer is 3, but instead is 6. and the oxygens are now balanced. But there's actually something wrong here. And I want you to think about it. What is wrong with this? Well, what's wrong with it is, does this 2 only multiply this oxygen? And the answer is no, it's not the only thing it multiplies. It actually multiplies this iron as well. And so we don't have 2 irons here, but now we have 4. So do you see how this 2 multiplies the 2 irons and now we have 4? And what I'm going to say is that's okay. That's okay that it messed that up. I know that we already fixed the iron, but what I want to highlight here is sometimes you will fix an element, and then when you go to fix a different element, it makes the first one not fixed anymore. And that's okay. Sometimes you'll fix one, and then when you go to fix another one, it makes it unbalanced. But we can go back and fix it again. So what can we put here instead? What can we put here instead to fix that? Well, instead of a 2, we can then put a 4. Before we had to put a 2 there, but now we have to put a 4 to make it balanced. And so now it is balanced. So again, sometimes you'll fix an element, and then when you go to balance another element, it messes up the element that you fixed, which is totally okay. You'll find that happens a lot. You just have to be resilient and go back and fix it. And so that's all good. So let's go ahead and go through these next ones. I'm going to go through this a little bit more quickly now. Okay, so we have this and we have this. There's, if you take a look, there's 2 hydrogens here. There's 2 hydrogens here. Oh, that works out. There's 1 oxygen. There's 2 oxygens. Okay. So the hydrogens are balanced and the oxygens are not. So how do we fix the oxygen? Well, what do we need to put here that multiplies the oxygen to give us 2? We need to put a 2 here. Oops. When we put a 2 here, that gives us 2 oxygens. Now, this 2, though, also changes the number of hydrogens. And so it turns out that when we put that 2 there, it actually gives us 4 hydrogens. And now the hydrogens are not balanced anymore, which is okay, because all we need to do is fix it on this side by putting a 2 here. And when we put a 2 here, that actually gives us the correct number of hydrogens. And that's it. So it goes 2, 2, and then there's nothing here, which means that there's 1. All right, next one, K, C, Cl, and oxygen. So this is going to be the last one that I do like this, and I'm going to show you how you can do these even faster. There's 1 potassium on either side, there's 1 chlorine, there's 3 here, there's 2 here. All right, so the potassiums are fixed, the chlorines are fixed, but the oxygens are not. And so again, this is a 3, this is a 2. You cannot just do this. You cannot put a 1.5, even though 1.5 will fix that. You can't do that because it's got to be a whole number. So you can't do that. Instead, what can both of these become? They can both become 6 by putting a 3 here and a 2 here. If you put a 3 there, this becomes 6. If you put a 2 here, this becomes 6. However, this 2 multiplies everything it's in front of. It's in front of potassium and chloride. So now we have 2 potassiums and we have 2 chlorides. And so that messes up the potassium and the chloride, which again is okay. Sometimes that happens. And so you have to then go to the other side and fix it now. Well, what do we need to now put here to fix that? We need to put a 2 here. And when you put a 2 here, that gives us 2, that gives us 2. And now it's balanced. All right. Let me go ahead and show you a way that's even easier. Let me show you a way that's even easier. You can actually just look at this, and you don't have to write anything. There's 1 magnesium. 1 magnesium. Okay, that's good. There's 2 manganese here. However, there's 1 manganese there. So all you need to do, you just need to recognize that there's 2 here and 1 here, and so it's, how do you fix that? By putting a 2 here. When you put a 2 there, it multiplies that and gives us 2 manganese. And then the oxygen, notice how there's 3 oxygen here and there's 1 oxygen here. And so all you got to do is put a 3 here, and when you put a 3 there, that gives us 3 oxygens on either side. However, you have to recognize that this 3 also multiplies the magnesium. And so now you have to ask yourself, well, is the magnesium balanced? And the answer is, no, it's not. It was balanced before, but now it's not. And so all you have to do is put a 3 here to balance it. It's that simple. Okay, let's do the next one. Zinc. Okay, the zincs are good. Hydrogen. Okay, the hydrogens are not good. There's 1 on the left and 2 on the right. So all you gotta do is put a 2 here because it multiplies that 1. However, this 2 also multiplies the chloride. And so now we have 2 chlorides on the left, but look at that. We actually have 2 chlorides on the right as well. And so now that's actually balanced. And so to balance this last equation here, you just need to put a 2 right there and it's balanced. Again, if there's nothing there, it's a 1. You don't have to put the 1, but you totally can if you want. And that's it. It takes a little bit of practice, but it's really not that bad. Once you get the hang of it, it is super easy. So that's it.